Okay, so what have we seen? We've seen we can visualize these correlations using scatter plots. And for the 3 high volume products, we need 3 plots. But if we then went to do the 5 medium volume, we need 10. Okay. And if we do 7 low volume, we need 21, because, as I said, it's 7 times 7 minus 1, 7 times 6 is 42, divided by 2 gives us 21 plots. And the 21 starts to get quite a lot of plots to look through to spot all the correlations. So one way around that is to use the idea of subplots, which I have mentioned previously. We've never looked at them so far. But the idea is to produce a single figure, one figure, but it's got lots of subplots in it. And this is useful in so many situations. So we could, for example, when we did the segmentation, we could visualize all the bar charts for the different segments in a single plot, doing it like this. So subplots are really useful. They're also known as faceting because each subplot shows a different facet of the data or the visualization. So how do we do subplots? Well, again, we're going to need these loops. So looking at this code, there's quite a lot to look at here, but don't get scared by that. So looking at the loops, it says for I, name I and enumerate for j. That's just the same as before. So this loop is going to loop over all those pairs. Okay, that's the just as before, we loop over all the pairs, except this time, rather than putting each pair in a new plot, we're going to put each pair in the same plot, but in a little subplot in that plot. So the way we do the subplot code is really the stuff in bold. We create the figure and add a title. So we can put the big title at the top. You can change the font and the position. We loop around all these pairs. So remember these 3 lines of code using the for loops gives us every pair of variables we're looking at. And then for that pair of variables, we add a subplot to the figure and we set the title, and then we draw the subplot at that point. And we increment the counter. So the counter is counting how many subplots we've got to, and it's used when we add the subplot. Often you'll find when you do this, the subplots will either they'll sit on top of each other, so they'll overlap a bit. So sometimes you need to do either of these two things. Maybe sometimes maybe not both, but either of these, where you adjust the space between them, the W space and the H space, that's the width and height space, or you use tight layout, which I think squashes them up a bit. So you may need to try those things. If your subplots are overlapping, then try those things. But once you've done that, here we've got that bit of code, exactly the same, except now I've put I've said what the selected are, the 5 medium volume. I've set the subtitle, so all these bold bits of bold are where I'm specifying these things. I've set them to say product sales correlations. That's the title at the top, and then the title for each plot, if you can see that, but this one top left says G versus H at the top. That's being generated by this sub.set title, which I'm just saying G versus H, because name I and name J are the names of the 2 variables I'm dealing with at that point. And then I scatter things. I've also set the size of the dots. So I've set the size of the dots to half the normal size, because otherwise they're a bit big and a bit imposing. Okay, but now that we've done that, we can start to see correlations. So you can see that H and J, I don't know if you can read that, but it says H versus J. That has a negative correlation, not very strong, but a negative correlation. H and S have positive correlations, and J has a strong negative, so they're much more tightly packed, and much stronger negative correlation with S. This is quite common, actually, to find that you get not just, if you get 2 variables that are correlated with another one, so J and S are both correlated with H, then it's very likely that J and S will be correlated with each other, because they're sort of doing the same thing, or the same thing in reverse if they're inversely correlated. We'll look at that more in a bit. Okay, and we can do the same thing again for the low volume code. This is then 21 plots, because as I said, there's 7 variables columns we've got to deal with, so that's 7 variables. And notice the only change I've made here, apart from changing the selected list, is that previously when we did fig.add subplot, so in the middle here, it's 4, 4. That means it's going to be a square of 4 by 4, so we'll get 16. In this one, we've got 21. 21 plots aren't going to fit into a figure that's got 16 holes, so we need 5 by 5, which gives us 25. I mean, these numbers don't have to be the same. It could be 5 by 4. That wouldn't fit 21. It could be 5 by, could be 6 by 4. That would fit 21 because that's 24. Or it could be 7 by 3, which would fit 21. So whatever numbers you put here, there's got to be enough numbers to fit the number of plots you're expecting. And remember, you can calculate how many plots to expect by using that formula. The number of columns times the number of columns minus 1 divided by 2. And there we can see there's one strong correlation there. M has strong positive correlation with O. Okay, so what can we tell from that? So remembering that correlation doesn't apply causation, what does it mean if one product is correlated? Well, it could mean lots of things actually, and we can't really tell what those things are because we don't have enough information to do that. It might mean that when somebody buys product M, they also buy product O at the same time. So, for example, if the store sells a table and chairs, but separately, people might buy one M and 2 O's at the same time, one chair and one table and 2 chairs. It might mean that some underlying cause so that both products tend to be bought at the same time of year. So ice cream and sunblock, for example. If it's hot, everyone wants ice cream and sunblock, but they're not really related directly. It's just related to the temperature. Same is true for negative correlation. So ice cream and gloves, you'd expect a negative correlation between those things. Or another reason could be that people are switching from one product to another. So from say a latte to flat white coffee, or some other switch where they or maybe the company's driving this. They're deliberately trying to stop the sales of one thing and encourage the sales of another thing. So that can again result in a negative correlation where one thing's going down as the other thing is going up. And I'm sure there are other reasons you can think of too. So correlation can come from a lot of causes. Our role as data scientists is just to highlight correlation and not to establish causation. That we leave to the business analysts. But once you've found strong correlation, it can make sense to group strongly correlated variables together. So if we see a strong correlation, it could make sense to think, well, if these things are always being sold together, then it makes sense to talk about them as a single thing. Maybe persuade the company to sell them as a single thing, but in the data, we could just think of them as a single thing because they always tend to be sold together. But we're not going to do that just now. Okay, I'm going to finish that video there, and then we'll talk next about heat maps.